Welcome to EDU World Space.
In this problem, we have a person trying to pull a nail out of a board with a claw hammer. They're applying a force in the horizontal direction of 150 newtons at a distance of 30 centimeters from the board here. The nail is embedded in the board at an angle of 30 degrees with the vertical. And then they give us this distance here to be 5 centimeters, and I take that to be the horizontal distance between where the nail is touching the hammer and the point where the hammer is touching the board. So if we take moments about this point here, so that these reaction forces drop out, we see that the moment caused by this force is minus F1x d2 if we take counterclockwise is positive. And then the moment caused by this force, about this point, we need to take the horizontal distance, or the perpendicular distance, from the force vector to the point here, so that's this distance here. Alright, so, and if we think that this angle here is theta, and so this distance here would be d1 over cosine of theta. Now, they get a different answer than I get, and I suspect from what I could figure out that they took a moment arm of d1 times cosine of theta, but I'm not sure how you could interpret that to be correct. This looks much more reasonable to me, that this is the horizontal distance, and then we need the distance, the perpendicular distance, which is that one, which is the hypotenuse of the triangle. Anyway, so that's what I used, and that's how I interpreted what this d1 was. And that gives a magnitude of this force of 779 newtons. Now, they ask us to figure out what the force vector here is. So we have two components, and we can then write this force vector in its component form, because we know the angle at which it acts and its magnitude. So here's the horizontal component and the vertical component of that force. And we can then write the force balance in vector form, so that we know that all the forces in their vector forms must sum to 0. We know this force here, we know because it was purely in the x direction, or in the horizontal direction. We know this from here, and then we're told that the hammer has some mass, so we know that. And we can plug everything in, and we get that the find F naught has a magnitude of 240 newtons in the horizontal direction and 684 newtons in the vertical direction, which is again different from what they get in the book, but I think they interpreted this in some other way that's not quite what the picture shows.